Alright, sketching graphs and stating the domain and range. So first up, y equals x squared. Shouldn't be crazy. A parabola. So we will just do a few points here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hopefully that'll be enough for us. So let's plug in x values and get y values. If I plug in the x value of 0, I get 0 squared for my y value, which is 0. If I plug in 1 for my x value, I get 1 squared, which is 1. So I get that point right there at 1, 1. If I plug in 2, I get 2 squared, which is 4. So I'm up here. And if I plug in 3, I get 3 squared is 9. Now imagine if I'm plugging in negative x values. Negative 1 quantity squared is also 1. So I get a symmetrical point right there. Negative 2 quantity squared is also positive 4. So I get a symmetrical point there. And negative 3 quantity squared is also 9. So we get another symmetrical point right there. So we get this friendly parabolic shape. We have these nice points, 3, 9, 2, 4, 1, 1, 0, 0, and then all of these pairs on the left. Negative 1, 1, negative 2, 4, and negative 3, comma, 9. So, let's state the domain and range. Domain of this function is going, ooh, that's a B, not a D. Domain of this function is going to be all real numbers. So there we say it in the set builder notation. In interval notation, I'd be saying x is in the interval from negative infinity up to positive infinity with parentheses because you cannot include infinity. Range are my y values. Notice that my y values are never negative. They're always positive or 0. So in set builder notation, we'd be saying y in the set of all real numbers such that y is greater than or equal to 0. In interval notation, we would say that y is in the interval starting and including at 0 and continuing to positive infinity. It's saying we can have all positive y values and 0 in that range. And there you have it. It's a parabola. It has perfect symmetry across the y-axis like that. And it's our friend.